My name's Brett Robinson. I work in the chemistry department. I'm an environmental chemist, and today I'm going to talk to you about some of our projects and more generally about the environmental science program. So although I'm a chemist, we work in other spaces as well. We work with biology, we work with physics and geography and geology. And today I'm going to talk about improving New Zealand's soils and waters. Now, why do we want to do that? What did you have for dinner last night? How many people ate meat last night? Any vegetarians here? Handful. Right, so you would have had some vegetables, had some meat. That all came from our soil, using our water. This morning you might have had milk on your Weet-Bix or your crusty flakes or whatever you eat for breakfast. Again, coming from our soil and water. Milk's particularly important. It generates $12 billion or so for our economy per year. It's our single biggest export earner, milk and milk products. All you vegetarians, of course, eat vegetables produced on our soils using our waters. And the cell phones that you're going to look at when you get bored of this seminar, what's that got to do with soil? Well, all these food products are major exporters, and as this enables you to be sitting here, this enables us to be able to buy our cell phones, our computers. If we weren't for our soils and waters, we wouldn't have any technology in New Zealand, or very limited. We wouldn't be able to come in, you wouldn't be able to sit here. We were absolutely dependent on our soils and waters for our whole economy. Not only food production, but also tourism. So agriculture's the biggest export earner. Tourism is probably the largest income in terms of industry. People want to come and see this. People want to eat food produced here rather than other countries. Why? If you're overseas, you'll see New Zealand product, people will buy it. Why would people buy New Zealand produce over, say, produce from Mexico or some other country? Ma'am? See it as more natural and more clean. So we've got to be absolutely confident, convinced that we can produce clean, healthy produce in this country to sell overseas. But if you dig beneath the surface, sometimes you find things are not entirely clean. For example, our sheep. If you buy or sell a sheep in New Zealand, it has to be free of parasites. Things that live on the sheep, suck its blood, etc. Now, to get them free of parasites, you apply pesticides. Now, this is a picture taken 60 or so years ago of a sheep dip. Does anyone know what the farmer is doing with that implement there? He's pushing the head of the sheep underneath the dip. Now, does anyone know what the dip contains? No, it doesn't contain DDT. It contains a chemical called sodium arsenate, which I hope you've all done at least fifth form year 11 chemistry. You'll know that arsenic is a chemical element. This is a periodic table of the elements. And arsenic, you can see the arrows there, is a chemical element. Now what that means is because it's a chemical element, it doesn't break down in the environment. Arsenic stays in the environment forever. It can move, but it never breaks down. So the farmer's put his sheep through this dip containing arsenic. The sheep comes out of a dip, it's dripping arsenic solution onto the soil. When the farmer's finished with the dipping, he would tip the excess dip out onto the soil. That arsenic stays in the soil. It doesn't break down, it stays there essentially forever. Now we don't use arsenic anymore. How many people are here off a farm? How do you get rid of parasites off a sheep now? Use a pour-on or a drench or one over the back. We don't use sheep dips anymore. But nevertheless, we've used sheep dips for many, many years. And we've used a lot of arsenic, and that's all in the soil. Now, New Zealand's population is growing, and our land use is changing. What once was a sheep dip or a sheep farm is no longer a sheep farm. We've got about 50,000 sheep dips in New Zealand, and most of them we have no idea where they are. Now this particular sheep dip here is in a place called Nitrification near Hamilton, and it's now an asparagus farm. So if you know how asparagus grows, little spear comes up through the soil with little bits of soil attached to it, and in this case a little bit of arsenic attached to it. So what we've done here is we've removed the asparagus and we've put willow trees in, which hold the arsenic in place and stop it from moving into the waters and into the food. Now, if you're going to buy a new house and it's a subdivision and it was a sheep farm, it might pay to have a look at the soil. Maybe do a soil test, because a lot of sheep dip farms are now found in a lot of sheep dips are found in someone's backyard. Very high concentrations of arsenic. So what you might say is arsenic. What do you know about arsenic? It's pretty poisonous. Arsenic can give you cancer and it can kill you. And, well, we've had these 50,000 sheep dips in New Zealand. Has anybody died as a result? Well, interestingly, the answer is yes. This is a picture taken in Wanganui back in the 1950s. In the foreground here, you can see a well. And in the background, you can see these gentlemen standing around what was a sheep dip. Now, the lady of the house, the farmer's wife, got ill. And then she died. And they tested her tissues and they found very high concentrations of arsenic. Now, arsenic's normally associated, those of you into crime novels, with murder. So the first thing they thought of when this lady died was, someone poisoned her. So the police did some investigation of the family. And they found the man of the house, James Walter Bolton, had been having amorous relations with the lass down the road. And so they convicted him of murder and they hung him. Or at least they tried to. So this was in New Zealand in the 1950s. Hangings were few and far between. And in this particular case, the hangman was a little bit out of practice. And he made the rope too short. So when you hang, you're supposed to drop so that the neck breaks and you die relatively quickly. Well, poor old Volta here, he didn't drop far enough, and so he swung there strangling to death and flailing his arms, and the whole process took 20 minutes or so, during which time the priest which was present had a heart attack. Anyway, he eventually died, and that was that, until the next person at the house started to become ill. Thought, hang on, what's the story here? Arsenic poisoning. Can't be Volta, he's dead. They tested the well here, found high concentrations of arsenic. So they thought, we better let Volta out of prison. Oh, we can't because he's dead, we hung him. So for those who have done chemistry, hanging's a non-reversible reaction. And this is historically important because of this case. This was the last capital execution in New Zealand. The capital punishment was abolished after this case. What about other contaminants we might find in our soil? Cadmium. Cadmium's a heavy metal. Cadmium accumulates in your kidneys, and in old age, it will make you very ill indeed. Like arsenic, cadmium is an element, which means it won't break down. So it stays in the environment forever. Where does cadmium come from in our environment? It comes from our fertilizers that we add to the soil, particularly superphosphate. We need to add superphosphate to the soil to make our soils productive, but it accumulates in the soil. So, for those of you who are from farms, next time you have a look in the fertilizer packet, have a look on the back and there will be something about cadmium. if the fertilizer contains phosphorus, there will be a warning and a concentration of cadmium in the fertilizer. And it says, use of this product may result in cadmium or lead or mercury residues in excess of the maximum permitted concentration in plant products, and may also result of the accumulation of these residues in soils. So we've been applying superphosphate fertilizers for decades in New Zealand. When we apply the superphosphate, we're also applying cadmium. This is an unavoidable contaminant in the superphosphate fertilizer. What happens is when the cadmium lands on the soil, it binds via processes called Cation Exchange and specific adsorption, which I won't explain to you now, but which you just have to take my word for, which means it stays in the top of the soil and accumulates. What that means is over time, cadmium concentrations in New Zealand are increasing. So this map, or these two maps here, show cadmium concentrations in different regions of New Zealand. And you can see in pre-2000, in the Waikato, we already have a lot of red dots. And red dots means cadmium above 1 milligram per kilogram, or 1 part per million, which is a threshold value for cadmium in soil. Once you get around 1 milligram per kilogram cadmium, the food that you start to produce starts to become contaminated with cadmium to the point where it's above food safety standards. Now, a more recent survey, but a less thorough survey in 2010, showed that cadmium concentrations are increasing, and particularly in Canterbury. So we've gone from a lot of yellow dots, 0.25 milligrams per kilogram, to blue dots, 0.75. So getting up towards that threshold. Why is that? What's changed in Canterbury in the last 10, 15 years? Yeah, we're doing a lot of dairy farming. Dairy farming needs a lot of fertilizer. We're applying a lot of cadmium. Now, although cadmium binds to soil, like jam to a blanket, plant roots here, so this is showing a lump of soil here with a cadmium bound to it, and this is a cross-section of a plant root. You have to imagine that the plant's growing up out of the screen. This is a cross-section. These plant roots exude chemicals into the soil. In this case, something called low molecular weight organic acids. Now, these acids solubilize the cadmium. That cadmium was bound to the soil and it solubilizes it. This results in cadmium being taken up by the plants. So even though the cadmium is binding the soil strongly and doesn't go anywhere, it doesn't leach, it is taken up by plants. And if you go down to the local supermarket and take vegetables and take samples, which we've done and which we will do as part of environmental science course at UC, you'll find cadmium in excess of the maximum permitted concentration in foodstuffs. So a lot of our vegetables aren't fit to eat because of the cadmium. So before the carnivores get too smug about that, cadmium's taken up by the liver and the kidneys of animals, particularly the kidneys. How many people here like steak and kidney pie? Okay, that's great because I hate it too. But don't eat steak and kidney pie because the kidneys contain really a lot of cadmium. So much cadmium, in fact, we can't export those kidneys overseas. So this is a loss of revenue for New Zealand. Now, I know the teachers are present, so you're not allowed to say how many of you smoke, and I won't ask you. However, when we used to duck behind the bike sheds and have a quiet cigarette, we were breathing in huge amounts of cadmium. Tobacco takes really a lot of cadmium. And when you breathe it in, this is one of the things that exacerbates lung cancer and is one of the many components of cigarettes which will eventually kill you. So what can we do about cadmium in our soils? This is a threat to our economy. How can we improve our soils? If we look at a market garden, and this one's from Levin, and I won't, for those of you who are interested in soils, you'll notice that the colour here is really light, and this means the soil's really low in organic carbon, which is bad. We want high organic carbon in our soil. This soil's really light, it's been really badly damaged, and so to get these lettuces to grow, you have to add really a lot of fertiliser. And you can see the little fertiliser granules down here. And of course we're adding also a lot of cadmium. So what can we do in this situation to improve the soil? Well, we can use wastes that we produce, things like composts, all the excess food and garden waste that we don't want, we throw out, we put it into the compost bin, which gets taken away. This is a picture from the recycling plant in Burnham. They can't get rid of their compost. We can put that into the soil. Now the compost can bind this cadmium and prevent it from being taken up by plants. So if you put the compost into the soil instead of the fertiliser, you significantly reduce the amount of cadmium that's taken up by plants. So this is pasture grass, Lolium perenniae, and this is the change in concentration. And you can see cadmium here, we've reduced it by 30% just by adding compost for 1 year. So we can significantly improve our soil by recycling our waste material instead of using mineral fertilisers. So that's enough about the soils. What about our waters? Our waters are essential for our food production. They're also essential for our revenue and tourism. You've all been whitewater rafting, I hope. Not on the Selwyn River, obviously. So this is the image we like to portray in our overseas markets. We want to say this is New Zealand 100% pure. This is clean New Zealand. But when the tourists come here, quite often what they see is green New Zealand, but not in necessarily a good way. This is Lake Forsyth, Te Waiwera, during an algal bloom. You don't want to touch this water. Touching the water will make you sick. If your dog goes swimming in the water, it will die. It's not the only lake to be affected in this way. This is Lake Waikari up near Hamilton. Do not touch the water. This is not what we want to portray in our overseas markets. We want people to come here for the clean, green image so our country can earn money and that we can enjoy our natural resources. New Zealand has the dubious distinction of having the largest outbreak of a nasty disease called Campylobacter ever recorded. And this has happened in 2016 in Havelock North, where over 5,500 people became ill. And the degradation of our waters come from the big four. This is nitrates, phosphates, sediments, and pathogens. So this is a real threat to our way of life and our economy. So what are we doing about it? We're looking at the chemistry of what's happening when this water's contaminated. Next time you see a cow peeing in the field, you can think 70% of the nitrogen that's entering our waterways comes from this event, from cows peeing. What's happening when Daisy goes for a leak on the field is she's adding equivalent of 1,000 kilograms of nitrogen per hectare in a very small amount of soil, far more than a plant can take up. And there's this chemical reaction occurring for the chemists amongst you, which is called nitrification. And when Daisy pees, she pees out ammonium or urea, which binds to the soil. That's okay because it doesn't move. But this undergoes nitrification to nitrate, which leaches into our waterways. Now, a few years ago, we had a compound that we could use called dicyandiamide, or DCD, which would stop this reaction, massively reduce our nitrate leaching. But unfortunately, some of our trading partners found this in milk, and we've had to remove it from our markets. So our nitrate leaching's massively increased. So this is not what we want to portray as 100% pure New Zealand. These dirty waterways, how can we change this? How can we make it better? We can't say stop dairy farming or stop growing crops because we need the income. That's the reason why you're here, is because of these activities. But we can relatively cheaply improve waterways through things like riparian plantings. So this is Boggy Creek near Lake Ellesmere, Te Waihora, showing massively improved water quality here with these native plants. There's quite a bit of science that goes on behind such plantings. You might think, oh, so we can just plant and put any tree in. What actually happens? We need to look at how the contaminants, the nitrogen, phosphorus, sediments and pathogens move across the soil and through the root zones of these plants. And we don't really understand how this happens. So that we can put these plants on farms and hopefully we can get a better environmental outcome. One of the major research focuses is understanding what's happening in the root zones of our plants. If you look at our native plants, they've all got really different roots. Science hasn't investigated New Zealand native plants very well. We've got 2,000 species of New Zealand native plants. We don't understand how 1,995 of them behave in terms of contaminants. We have been looking at one or two though. So we send our students down holes. They put in equipment to measure chemicals that move through waters. They find new things like new species of native earthworms that have never been described by science that also affect the transport of these contaminants into waterways. You've all heard of Manuka and Kanuka, two of our native plants. One of the things you might notice when you see a Manuka and Kanuka is it has this really nice smell. That's caused by specific compounds that these plants exude. Things like caryophyllene, alpha-pinene, cyamine. These things do interesting things in the soil. We have tested these plants using lysimeters, devices that measure the leaching of contaminants through soils. And we've found that compared to pasture grass, Manuka massively reduces nitrate leaching. We think we know why, but we're not 100% sure. We think it's to do with these compounds that Manuka exudes. We've found that Manuka kills pathogens in soil, so things that will make you sick, like E. coli or Campylobacter, Manuka kills them. So if we put more Manuka in next to our rivers, we might improve our water quality, but we might not. What's a recent event that might affect Manuka in New Zealand? Myrtle rust. So we can't just go and cut everything down and plant Manuka because it might all get wiped out. So we need to keep looking. We need to make communities of plants. We're also mindful of the cost to the farmer or cost of the restoration practice. Can we combine the production of honey, which is worth $300 million to our economy, with our waterway improvement? Can we clean up the waters and make a lot of money at the same time? So these are the types of things you can study at UC if you do environmental science. So we learn about different environmental issues and potential solutions. If you want to do environmental science at UC, you do it as a double major with another science subject. So if you like chemistry, great. I encourage you to do chemistry, but if you hate chemistry and you want to be a biologist or a geographer, hey, you can do that too. You can do geography or geology or physics and environmental science. It's interdisciplinary. And then when you've got your degree, you will get a job. There are jobs with consultancies with Department of Conservation, with farming groups, mining companies, government bodies. There are a lot of job opportunities for environmental science graduates. Or you might decide to become a researcher and develop new solutions. So you can find out more about environmental science at the Public Open Day on the 16th of April from 3 to 6. And before you leave, please take an environmental science brochure. Thank you.